Hello everyone. In today's lecture, we are going to discuss about electric potential and potential difference. Now, I hope you remember we have already seen what is electric potential in the topic electrostatics, right? So, one more time I'm going to discuss it with you because this is really important or necessary for the current to flow in a conductor or a circuit, right? So, in the previous lecture, as we have seen, there was a battery source of potential difference, right? So, the charges cannot move from one end of a conductor to other end, as we have already discussed it, right, in the previous lecture, that because they have random motion and the net displacement of the electric charges or electrons specifically would be zero, net displacement would be zero. Now, in order to make them move from one point to other point, altogether the charge, that is number of electrons, right, we need one electric pressure or driving force. For that we need to create potential difference, and that is created by battery. Battery is nothing but a cell, okay, a cell or group of cells which we call it, okay, a group of cells where the chemical energy is converted into electrical energy. I hope you got that, right? So, potential difference needs to be created across the conductor in order to make the charges flow in a conductor. Let's draw the conductor once. Suppose this is our cylindrical conductor over here, okay, and now I have connected this across a battery or a cell, okay, cell or battery, same thing, group of cells is called as battery, okay. A cell is nothing but a device which supplies electrical energy, okay. It's a chemical device. Chemical energy is getting converted into electrical energy, okay. Now, as you can see, this is positive terminal, this is negative terminal. So, this potential or potential difference, as you can see, since this end is connected to positive and this end is connected to negative, as you can see, there are two ends at two different potentials. So, potential difference is created and the charges are forced to move from positive terminal to negative terminal, or as we can say, electrons moving from negative to positive terminal, right. Now, so electric potential is nothing but a driving force which makes the charges flow in a conductor from one end to another. So, basically in simplified manner, what can we say? That potential, which is expressed as V, is nothing but work done in order to move the charge Q from one end to other end, as we have already seen this in case of electrostatics when we were finding out the potential of any charge capital Q at a point P at a distance r, and we measured it by bringing one test charge from infinity. I hope you remember that, right? So, over there we defined the potential of charge plus Q or capital Q by saying that work done W needs to be done in order to bring the test charge, and upon test charge, that is Q naught. I hope you remember, right? So, in our electricity case or electric current case, the amount of work done, suppose this is a cell or battery and its potential difference or potential simply is given by V. So, the V does the work, okay, does the work to make charge Q to flow from one end to other end, okay, and the charge flowing from one end to other end is nothing but current. I hope you know that, right? So, now the potential, electric potential and potential difference is nothing but the work done by the battery or the cell in order to move the charge Q from one end to other end. So, from here what can we say? 1 volt is the potential or potential difference in order to do 1 joule of charge, okay, which does 1 joule of charge in order to move 1 coulomb of charge. You can say in that way also. So, 1 volt potential or potential difference across the conductor is nothing but 1 joule amount of work done in order to move 1 coulomb of charge. In that way also you can say. And potential, of course, is a scalar quantity, right. So, electric potential or potential difference can be given or can be established across the conductor through a source or by the help of a source, and that source is nothing but a battery, or in higher classes you will see AC source also, which is not a battery, of course, okay. We will see that afterwards, but as of now you just remember that the electric current is established in a circuit or a conductor by creating a potential difference, and that is done by the battery or cell, okay, or source of potential difference. Now, over here, how does the electric potential and the potential difference across the conductor makes the current flow, which we have already seen some hint in the previous lecture, that is, it creates a electric field, it creates an electric field, okay, it creates an electric field inside the conductor, okay. And the charges, especially, of course, we know the charges are electrons. The electrons, they experience force due to the electric field, and all they move in opposite direction to the field, because they experience force. F equals to minus EE, isn't it? F equals to minus E, that is the charge, and this is the field. So both are vector quantities. Therefore, electrical charge, that is our electron over here, they experience force in opposite direction to the field of, in the direction of field, opposite to the field direction, we can say that way, okay. So over here, if they experience force in that way and they move from one point to other point, so we can say that the positive charge will do exactly opposite, that is moving from positive end to negative end, as same as the electrons do, moving from negative end to positive end. So bunch of electrons or bunch of charges moving from one point to other point is nothing but current, and that is only possible if we supply the electric potential or potential difference across the conductor with the help of a source or a battery. I hope that is clear to you, right? Let's see one figure or circuit diagram which will help you to understand in a better way. So as you can see in the picture over here, previously the first picture over here, where the battery is not supplying the energy, or battery is not creating any potential difference because the switch is off over here, because we are not giving its full complete circuit, okay. We have not created a complete loop, okay, closed loop, because the switch is off. Now when the switch is on, the battery is providing over here the electrical energy, as you can see, because it creates a potential difference, okay, across the bulb over here. So bulb is the device which we are showing in order to, or showing which uses the energy over here, electrical energy, and converts the electrical energy into light energy. So in a circuit, the devices which we place or which we join are there to consume energy, okay. Otherwise, why will build a circuit, isn't it? Just like the house wiring. In a house, we have bulb, we have tube light, we have TV, we have this fan, right? So all these devices are electrical energy consuming devices, okay. So they consume energy. So that's why, as you can see, if the battery is off, if the switch is off, the circuit is not complete. If the circuit is not complete, the electrical energy can't flow by making a potential difference. As soon as we switch the circuit on, okay, the circuit is complete and the potential difference is created across the conductor or the bulb over here. So when there is a potential difference established across the conductor, the current flows from higher potential to lower potential, that is from positive end of the battery to negative end of the battery. And when the current flows, that current delivers the electrical energy to the lamp over here. I hope you got that right. Now let's solve some problems based on electric potential and potential difference.